Dale has been working as a plant ecologist in BC for the past 44 years. Amongst his many accomplishments, he led the development of something called the Biogeoclimatic Ecosystem Classification System and contributed to the development of ecosystem mapping protocols for BC and map accuracy assessment standards. His field experience is throughout BC, collecting field data, correlating biogeoclimatic mapping and field guides, and assessing ecosystem mapping. Recently, Dale expanded biogeoclimatic mapping to the northwestern states as part of a program to determine which tree species will be suitable in BC under climate change. Dale?
Okay, that's good. I think so. Well, good morning. Yeah, I guess the important part of my background is that I have been a practicing ecologist in BC for quite a number of years, and working on the Biogeoclimatic classification, I've thought a lot about climate and forests and what gives us the different forest types that we have here and all over BC. And then then this thing called climate change came along. We weren't really thinking about it early in my career. We thought we were developing something that would last for centuries, only to find out that the climate was changing and that would have implications to the forests in BC and their distribution. So I got involved in some projects looking at what are the possible impacts of climate change on BC's forests. And I'm going to talk a little bit some that I'm involved in, but with others, of course, because there's lots of people working on this. Uh-oh. What happened?
Oh, the down.
Oh, down.
Yeah.
Okay.
Counter.
So the budget, I don't know, has anyone seen this red book? Has anyone used this in forestry? There's a few hands came up. So basically, Grant mentioned the Biogeoclimatic classification, and so yeah, it's mapping of climates and what forests occur in different areas, but also this is the guide for the coast, which is called the Vancouver Forest Region at the time. And so it just arranges the different forest ecosystems in a bunch of ways to help people identify them in the forest and learn how to manage them differently. So this is just a grid then that we put the different forest ecosystems on, from very dry and poor in nutrients to wetter and richer in nutrients. And we could go into all the reasons why that happens, but just so you know, there's a variety of ecosystems that occur out here, and this is a guide that can help you describe them, and so that, oh darn, I'll get this figured out. And then, so besides that sort of main grid of kind of dry to poor to wet to rich, there's sort of a couple other grids in that book about, these are strongly fluctuating water tables. So winter wet, summer dry. So there's a few that occur on this grid, and actually all three of these occur on Hornby according to some mapping. And then these are what would happen on, say, river floodplains, high bench, mid bench, and low bench. So anyways, that's the variety of ecosystems that occur, and in that guidebook it has a list of all the species trees and understory species and mosses and lichens sometimes that occur on each one of those. So that system was applied then to the coastal Douglas fir zone and other areas of British Columbia. And this is the map of Hornby Island. This is just looking at the label is just the predominant ecosystem in there. They map up to 3 different forest ecosystem types within each polygon. But so like DS, Douglas fir salal, that's kind of in the middle of that main grid. It's kind of all over the map. This whatever color, pink, bright pink. And then the red cedar, grand fir, foam flower is RF. It's these kind of blue areas kind of occurring along sort of some drainages and things. But anyways, there's a fair bit of rural and cultivated field. So, but anyways, that's just an example of an application of this at a local area. So these are the forest ecosystems. So it's mostly, as you can see on that map, the 01, the 01, it's called the 01. Douglas fir salal, 52% of that map area. So that there may be more of it in the rural area, but anyways, what was mapped outside of rural these are the percentages. So a little bit of Gary oak, brome, mixed grasses, only 1% say, but Douglas fir, lodgepole pine arbutus, or short pine arbutus, 1%. So you can see that predominantly, anyways, of the forest, this O1 ecosystem. And it also maps some of the non-forested ecosystems, but like, you know, which are a small percentage, 3% of that area that was mapped, of which a small proportion are kind of, you know, wetlandish kind of ones, like the hardhack Sitka sedge or the shallow open water ecosystems, but and then drier ones like the rock outcrop communities and cliffs. Cultivated field and rural, that was urban, suburban, so 25% in that case. So the other part was, when they do this mapping, often they map the terrain, the kind of parent materials and the drainage of those soils. And it's kind of interesting here because most of Hornby is glacial marine. So it was formed at the melting of the glaciers. A lot of these deposits were laid down. And they're a sandy, gravelly glacial marine sediment. So that means they're, you know, a little bit on the dry side of things, which could help make, you know, it has some implications to, say, drought conditions and what might happen. Sorry, it was, you know, 76% of the island is that glacial marine, this WG here. And then there are some other parent materials, like colluvium, which is like gravity parent material. So those are kind of rocks falling off the top of the mountain and forming, again, a fairly coarse sectioned material. Rock is 1.2%, this sort of thing. But the point is that very little is, say, of the kind of wetter things like fluvial or marine or organic. So here they also put in, say, soil drainage, and, you know, this is what's been mapped. You know, maybe been out on the ground and measured it all. It might not be exactly this, but this gives you, again, a pretty good idea. So again, things that are a bit moister, like imperfect, poorly drained, very poorly drained soils, it's only like, you know, just over 10%. So 90% of it is things that are kind of moderately well drained to rapidly drained. So if you said, you know, what is the ecological context then of Hornby Island? So 70% of it, at least, is forested ecosystems, mostly that mesic Douglas fir forest on well to moderately drained glacial marine sediments. That's just kind of summarizing the main things from that map. The drier forested ecosystems are only about, say, 2%. Strongly fluctuating water table ecosystems, and surprisingly, because we've got these coarse materials, comprise 8% of the island. And that was those units on that little strongly fluctuating water table grid I showed you. And wetlands are like less than 1%, at least according to this mapping. Anyways, that's the context for Hornby. We'll come back to that a little bit later on. So right now I'll kind of go off and talk a little bit about how people have looked at how climate change might affect the forests. And, you know, unfortunately this isn't up to date to this minute, so 2023 and possible extremes might make things even worse than what I'm going to say here. But anyways, I'll give you the background of what some people have been doing. So there's kind of two main approaches in a sense. Bioclimate modeling. So that's where you look at future climates and then you say, okay, this climate here changes. What does it change to? What's an equivalent bioclimate somewhere? And then you look and maybe find out what that is, and you say, oh, okay, so we're going to get, you know, possibly we could grow different tree species, or we're not going to have some of the tree species we do have, or some other things are going to change. So that's the idea behind bioclimate modeling. Just taking today's climate, comparing it to, like taking future climates for, say, an area like Hornby, and looking at where is that equivalent? Where's the equivalent climate? And then species modeling is doing something similar, but taking, taking tree species and what we know about their tolerances, and then saying, okay, what kind of temperature differences can they tolerate? What kind of moisture conditions can they tolerate? And looking at what might happen in that case. So one of these, that actually the map that I had on the left there, the series of maps, was looking at biogeoclimatic mapping in BC and saying, what might some of these zonal things change? And so here's the coastal Douglas fir zone, and in the 2050s, say, compared to in the 2080s, so going forward, there would be some loss of area which is presently coastal Douglas fir zone. It would no longer have a climate that's equivalent to coastal Douglas fir zone. And then some areas, though, would be new. They would now have a climate that would fit in the coastal Douglas fir zone. And so, anyways, so net change, not much change from the 2050s. An increase in coastal Douglas fir climate, say in British Columbia, in the 2080s. And then a bit of an elevation shift, at least according to this model. So the authors of this, Tong Li Wong and others at the bottom there, they said, this is relatively unchanged compared to the other zones in BC. It's just, so there's even, bigger changes in some other zones. So this is now a study that was done in the Pacific Northwest in the US, and they were looking at various tree species. I just pulled out a couple here. And in this case, so we got Douglas fir and Gary oak, and it's looking at different climate models. So no one really got into this, but an RCP is just the amount of CO2 and other greenhouse gases in the atmosphere and what they're projecting what might happen over time. So 4.5 means it's kind of a moderate increase in greenhouse gases, and then 8.5 is a more extreme scenario. And then there's different climate models. So a climate model then is how does the whole climate system work on the planet, and with changes that are going to go on, how does that affect things? So, lots of people run a model, and there's different results. And so this is looking at two different scenarios for greenhouse gases, and then two different climate surface models. And anyways, for Douglas fir and for Gary oak, this is showing decline in area. There's nothing above the line, above zero. So it's showing a decline of, whatever, a little bit to up to 30,000 square kilometers in the Pacific Northwest of the US. And then same with Gary oak. Well, same thing, yeah, right. So just a decline, though, a more significant decline from, I don't know what that is, maybe 25,000 square kilometers down to maybe 125,000 or more. And this is just looking at the percent change. So anyways, it's showing, possible, significant changes in the areas where these tree species are suitable and productive and whatever. So another guy, Ray Felt, a while back, looked at this as well, and these were just some of his statements. So coastal Douglas fir habitat would remain climatically suitable by the 2060s. Most of it would remain suitable by the 2060s. So an 18% of future habitat, so it would expand by 18% is what he was saying back then, into area that presently does not have coastal Douglas fir. But this is interesting that 24% of area that's presently occupied by coastal Douglas fir would have genetic stock that is projected to be maladapted. So it's not, it's going to be, those species are going to be, the Douglas fir will be struggling on those sites. So here's another one about Gary oak, and this one they looked at both BC and Washington, Oregon, and they said that, as kind of that other one said, climatically suitable habitat would increase, but the key thing here is that a lot of it isn't really connected. And so, even though you got new habitat, can the species actually migrate to that habitat? And of course, how long would it actually take and things like that? So those are some of the definitely issues. But just I'm going to sidestep a little bit here and say, okay, so we've got changes in species. What does that mean to Hornby Island or anywhere in BC? And we kind of know, because everyone here knows some of the main species on Hornby Island. A lot of those are quite wide-ranging. So the species could have quite wide tolerance to changes in climate. Here's just, Granite kind of showed you Douglas fir distribution map, but here's kind of Douglas fir, western red cedar, and arbutus. And they go all the way down to southern Oregon and into northern California. Unfortunately, this date, I didn't think I had to go too far down to California. This data source I used is just herbarium records of these species, and so it doesn't include California. So they go a little bit into California as well. But so all those species are quite wide-ranging, and they're not just in coastal Douglas fir habitats. They're, as Grant also mentioned, Douglas fir occurs into the coastal western hemlock zone and other zones as you go south. So here's Gary oak, going again right down to California, and grand fir, both on the coast and the interior, slough and ocean spray. So there's very similar, distributions here for all of these. They're heading dull Oregon grape, sword fern, salmonberry, all wide-ranging. But the question is, what genotypes do we have here? Are the genotypes here adapted to that full range of conditions, or is it a narrow range? They were all migrated here after glaciation, of course, and we don't really know their genetic adaptability. So, yeah, how well are they adapted to future climates? The increased temperatures, the climate extremes that we've been talking about, drought, flooding, heat. And then the other thing is that, these are great. You've got these model predictions about what could happen to climate or species distributions and things, but as I kind of said a second ago, can the species actually migrate here in any timely manner? Probably not. We're in an island, quite isolated from some of the main distributions of those species. So assisted migration is something that people in forestry in particular are looking at. And there actually is quite a bit of research on this throughout, not just in British Columbia, the Pacific Northwest. But already, say in British Columbia, we are moving genotypes in our species, like Douglas fir. Through the tree breeding program, they're looking for the best, genotypes, and they're putting those out in other areas. So you're moving species that were, say, from one area to another, and they're also then looking at future climates and saying, yes, we can push them maybe a little bit north in latitude or whatever because it's going to be warmer up there in the future. So that kind of thing is already happening. Also moving species like western larch further north from its present distribution in BC. And that's partly also, that is kind of based though on some trials that were set up quite a number of years ago where they could show that western larch can grow, say, even around Smithers quite nicely actually, and produces very nice looking trees for forestry. But anyways, there's a new tool that we've been looking at, and that's why I have this map on the right here which shows, this yellow coastal Douglas fir occurring down in central Oregon in Willamette Valley. You probably already knew about that, but down here in southern Oregon, northern California. But anyways, this is a bioclimatic map now we did most of the western states, and it's being used now within BC to try and look at what could happen, what tree species might be suitable going into the future. And I'll show you a little bit on that. So this is a little bit fuzzy, but we'll look at it anyways. This is one of those, that same grid that I showed you earlier with the ecosystems, but now it's going into the tree species, Douglas, where they're suitable. So this is the present condition. So Douglas fir, cedar, those are the codes based. So Douglas fir, grand firs, western red cedar. But now let's say the future climate was still CDF, but this one, let's say way down in southern Oregon, northern California. Well, now all of a sudden we have a bunch of different species. So Douglas fir and Gary oak on zonal sites, plus things like sugar pine, incense cedar, way more arbutus, this sort of thing. So what it means that is if you dropped a pin on this map and then in the future it said, yes, this climate could be here, well then all of a sudden you might say, well, should we start thinking about planting sugar pine or something? And so that's how this would be used. This is just a little bit of using that same thing but applying it, looking at a little bit further in BC. This is, I'll just show this kind of quickly, but this is, say, the present distribution of Douglas fir in BC, and colors just mean whether it's kind of the main recommended species or a secondary species or even a tertiary species. That's the colors there. And then this is the future at 2050, and it's the red colors are where it's going to decrease in potential, and the blue is where it increases in its potential. Same thing here for western red cedar. So here's its present distribution, and then you can see it's actually quite an increase in the central interior, and that's partly because it's warmer and wetter, which means it's more suitable for western red cedar. It's hard to see Vancouver Island and things, but you can see it's red down there anyways. So a projected decrease in suitability for western red cedar. That same model that I'm doing the bioclimatic part, there's other people doing this part, Colin Mahoney and Will McKenzie. But we can also look at it by site. So these are poor, this is looking at, this is, I think, lodgepole pine, oh no, spruce. This is looking at spruce, but it's just, I put this on here just to show you that we can look at, say, poor sites, dry and poor sites, medium mesic sites, or those wetter, richer sites, and still run the same model. And so that kind of gives people a little bit more information than just broadly what might happen. And some people use what we call consensus models, and that's they run a bunch of these scenarios, maybe up 15 of them or 30 of them, and they say take what the majority of them say, and that's kind of their conclusions. Other people look at the full range of outcomes and try to offer up the possibility, all the possible futures based on those model assumptions. So that one that we're working on right now for, looking at the US and up into BC, we're looking at a variety of sites, and we're looking at the full range of outcomes. So it's trying to be a little more complete. But as I said, it doesn't include, rapidly perhaps changing climate that we might be seeing over the next few years. So we'll have to be updating the model. So climate change impacts then in general. Shifts in climate will result in, deterioration of growth, health, and survival in forest ecosystems. We already have seen climate change impacts in forests in British Columbia and on Vancouver Island. And this is just something I found from sort of like provenance testing. So provenance testing is where they take a tree throughout its range, take seed from throughout its range, and grow seedlings and plant them in different latitudes, say, throughout its range again, and see which of the genotypes actually are successful in a broad range of sites, which have problems and that sort of thing. So what they showed is that for the genotypes that are maladapted, so not adapted to the particular climate condition they're planted in, there's a loss of productivity, increased environmental stress, and then mortality from various agents, like fungi or insects and whatever. So then, thinking of the forest health of the CDF, the coastal douglas fir zone in general, historically we've modified things in the last 100 and some odd years from both like the disturbance regime, as the natural fire regime or whatever else, the disturbance regime has changed. The First Nations burning and things like that no longer really takes place. So, things are different in the CDF than they used to be. There's evidence of increasing red cedar death. Arbutus leaf blight, some people attribute that to, this species is somewhat maladapted to the present climate, and so it's having some problems. And there's Douglas fir death around, but it's not always, it's hard to be certain that it's climate change just yet, but it may be. So for Hornby Island then, there's likely to be, say, an increased frequency of stand disturbances, fire, insects, and pathogens. We don't really know the adaptability of all of the trees and the vegetation here. And we don't really, as I said, migration could be an issue. The effects of droughts, though, so we're expecting, say, more droughts, more severe droughts. And as I said, because the textures here are coarser in general than, say, other parts of, say, the coastal Douglas fir zone, we might expect to see a greater impact of drought on Hornby, say, than some other areas. Some sites may become too dry for trees. For moisture-loving species, they may not be able to survive that summer drought. What would you do to make more resilient forests in Hornby Island? And so, you might think about increasing tree species diversity and genetic diversity over time. And like I say, even maybe bringing in assisted migration. One thing I meant to mention there too was that species that are occupying the site now, even though they may be maladapted, might still survive for quite some time until there's a disturbance of some sort. And then you may find that they could no longer actually regenerate on that site. So it's kind of like they're there and they're surviving, but the conditions may not be right for germination and regrowth. This is my last slide. Just it's getting antsy. This is just a little plug. So here's a new grid for the coastal Douglas fir zone, because we're updating the coast region field guide. It should come out next year. And So it's not that the ecosystems have necessarily changed all that much. I mean, there's some, if you took this one and compared it to the old one, they're fairly similar. Just putting it all on one grid instead of multiple grids, and adding some non-forested ecosystems, and there's more recognition of hairy oak in this one. But the advantage will be that there'll be a lot better tools for how to identify these things in this new guide compared to the old one. So if maybe you don't want to pick up the old one, just wait till the new one comes out. Okay, so questions?